Are you able to see my slides?
Not yet. Yep.
Awesome.
Nice.
So greetings everyone. A warm welcome to Exchanging Ideas 22 Global 5G Evolution. To the audience around the world, please take a few seconds to click the subscribe button on our YouTube channel Global 5G Evolution. And a big thanks to the speakers from all around the world to make available their time to present in this event today. So let me start with my topic title known as 10 Hot Consumer Trends 2030, the Hybrid Mall. So this is a hybrid mix of connectivity-enabled technology integrated into a real physical environment to enhance the shopping and buying experiences. And it is expected to be a common element in everyday life in 2030 by the vast majority of current early adopters. And this is a prediction that with the findings from the latest Ericsson's 10 Hot Consumer Trends report. And this survey was conducted by the Consumer Lab, where they have done some sort of survey from global early technology adapters that sums about 57 million of variety of people from various industries. And basically the 10 hot consumer trends is based on under one shelter known as the Every Space Plaza. And this is a place that the next generation of connectivities and high-tech gears are being placed for the users to experience the next gen of hybrid mall. So to start with the first key trend, this is known as a all now arena, where you could be both actor and spectator, and where nearly 8 out of 10 consumers envisage event halls where telepresence technology allows artists to digitally perform as if they were there in person. And this is something, a new trend where, you know, AR, extended reality can be applicable in concert halls, sports arena, interactive museums as well. The second key trend will be the hybrid gym, where for many physical, vigorous, and mental health are intrinsically linked. 7 out of 10 consumers have actually given or expected the mental fitness centers that have a multi-sensory and a personality tailored AR, VR scenery to help improve the mental health. The third area is the medical multiplex center. This is quite interesting, where we are used to everything being instant, right? So where why we should wait when it comes to health, why we should be queuing in the hospitals or the clinics. And 77% of consumers foresee in more medical centers with the drop-in AI health scanning that gives a near instant health status updates. And number 4 is the never-ending store. This is quite interesting. Try before you buy, virtually at least. So 3/4 of the consumers in the survey has expected to be able to project their home inside the store, where they're trying to experience new products, right? So this is a very kind of different kind of experience using the extended reality. The other part is using the 3D printing, where this is known as a print a wish multi-factory, where on-demand repair and production are the future. And over half of the consumers want to drop sustainably in a factory outlet that recycles the old products. So anybody who wants to push all their old products and get it repaired and come out with a new production, that's where the sustainability shopping print 3D machines can be the future. And the next key trend is the Meta Tailor. Meta Tailor is quite a popular, where fast fashion tailored just for you and your avatar. More than 7 out of 10 AR VR users have foresee a tailor in the mall using the fabrics that can switch to become waterproof or provide a ventilation when needed. And these are the robot sewing machines or 3D printers that can able to produce low-cost custom-made outfits instantly from the Meta Tailor perspective. The next is the immersive beauty salon. The immersive beauty salon is some sort like an attractive option for many, where they can use the volumetric modeling technology to digitally enhance the looks as expected in malls. And 7 out of 10 consumers have actually identified that this AI selected, new way of color patterns, surroundings, or with the hairstyle or the makeup, facial, all this can be done with this kind of immersive AR, VR application. And then the next is the restaurant at the node of the universe. This is quite interesting, where the distraction is free. Virtual companies is preferable for many, like half of consumers wants to visit restaurants to virtually eat with friends in other restaurants and any part of the world, right? So anybody can able to meet anyone with an easygoing, rather than being serious in virtual meetings. They can have it in the restaurants, where they can cheers with their drinks and their food and with laughter. And this it's expected that can be a major trend by 2030. The other area is the Anyverse pool, where many imagine the exploration of impossible worlds. 2/3 of consumers believe there will be a swimming pool where you can use an oxygen-generated VR headset to experience the outer space in zero gravity. So this is 100% of an XR pool. Some tests has been going on. Some research is going on by Ericsson as well. So this could be the next trend. And lastly is the nature plus park, where for those stuck in the cities, nature may be that's going to be missing. 42% of consumers want to visit an in-mall park where they can feel closer to nature through digital and programmable materials that provide hybrid experiences. So they don't need to go and look out for zoos or museums. This can be some sort like a virtual interactive real-time zoo in a hybrid mode. So this is the overall of 10 key consumer trends, and all these technology facilities can be placed under one building known as the Every Space Plaza, where, as I mentioned earlier, like the Meta Tailor or the Never Ending Store, the restaurant of Node of Universe, the medical multiplex center, the pre-Navish factory, the immersive beauty salon, the Anyverse pool, all these can be located in different floors as in a hybrid mall, where the anyone can able to experience the richness of the technology. So this is overall my presentation for today. So I would like to pass on to the next speaker. Let me introduce Associate Professor Adrian Klicks from Poznan, Poland, to present on the edge intelligence supporting autonomous platooning.
Okay, welcome. So thank you for a warm introduction, and also for inviting me for this great event. So as it was mentioned, I would like to present the concept that I'm working jointly with my friends Paweł Sroka. We are representing Poznań University of Technology and the spin-off company Lumina Labs. And with this talk, I would like to present the concept of edge intelligence applied to support autonomous platooning. So what is one of the key drivers also in 5G and 5G and beyond. So the way how we could apply some edge intelligence, intelligence close to the driver, but not inside the car, is very important for in our case. The outline of my talk is the following. So briefly, I will provide the motivation of this work, and that we will focus on specific use case, which is a vehicular dynamic spectrum access. But I will try to generalize it in the next part. Where I will talk on this edge intelligence, in fact, some databases intelligence supporting decision-making process in the context of autonomous driving and autonomous platooning. I will show brief example on application of Q-learning, a distributed version of it, and try to generalize it after all to show the concept. So as we all know, and as we had chances in the previous global 5G meetings, we saw many. We saw that the way towards autonomous driving is really very fast, and we see every year, every month. In fact, we see the new developments, the new. I don't know if you see the screen well. Something wrong is happening. Okay, so in fact, we know that there are many investigations and many great results that we are able to see also during the previous meetings. I mean, something's wrong with the graphic. I don't know what. Anyway, if you look on the 5G scenarios, the 3 scenarios that have been considered in 5G and also they are considering to be extended in 6G. These are extended sensors, so we could have exchange of sensing results between the cars and between this infrastructure. So this is the first one. We should consider this autonomous and remote driving. This is the well-known approach. And the third one that I'm working particularly with is the platooning. So we have a leader and there is the train of the following cars, which follows the leader. The leader and platoon can be created either dynamically or statically. So these requirements, these scenarios that have been considered in 5G and, as I said, will be extended to more advanced cases in 6G, they are associated with very strict requirements. As we can see here, I will not go into details. You can later see on YouTube the details and the numbers. But just to highlight that, as we know, the reliability of communication and the reliability of data exchange has to be very high, and also the latency should be as low as we can. And this generates some challenges. We know them, just to mention some of them. So we will have, as we have many cars, then the amount of data, if we have this crowd sensing and the autonomous driving, the amount of data that has to be transferred through the wireless communication links, this is enormous, you can say. Also, we have to guarantee the high reliability and this ultra low latency. And we know that, in fact, in many cases, there will be no central controller, at least up to now, and the network is of sort of ad hoc. These are all great challenges we have to face, and in fact, we are doing this. In terms of this requirements toward the wireless communication, we have 2 approaches. Just to recap briefly, on the right side, we have this cellular V2X, where we use infrastructure and the cellular networks. On the left side, we have this IEEE 802.11p based solutions, which are widely known as DSRC-K. So the left one is more distributed, the right one is more centralized, just to recap where we are. But as we know, and all the investigations and measurements, they confirm that in fact the amount of spectrum that we have, if there will be a high traffic, as we can see here, heavy traffic on the road, there will generate also problems in the spectrum. So we need simply we need more spectrum to that case, and this brings us to some problems. There are of course move towards increasing the communication band associated to or dedicated to this kind of traffic, but there is also another way that we could associate, we can assign some unused frequencies to these communications when needed. And this is just, of course, this is a specific example that we are searching for some dedicated frequency bands for V2X communication. But this should act as an example that we can think about the application of edge intelligence. So in our case, what we are considering in our research is that we would like to select some frequency bands not originally applied to this V2X communication. So in that case, if you try to generalize it, so of course I will show the results in that for that scenario, but if you try to generalize it, the concept behind this edge intelligence is the following. So we can imagine that we have some autonomous cars. In this case, we have this platoon of trucks. So if we will have these platoons, they will need to discuss between among them within the platoon. But then also they have to exchange all the measurements and the data between the base stations or roadside units. And in fact, this roadside unit should be equipped with some processing data, and it should apply some advanced techniques and advanced algorithms to support the driving. In fact, all the computation can be so heavy that, in fact, this infrastructure should support the cars in making good decisions. So, of course, there could be some dedicated, it could be a layer structure. So we will have some global domain where we could save some globally applicable data. And something which will be highly related to the local, to the specific location on the road. So the concept here is that we should apply, in order to support this autonomous driving, there should be some intelligence also close to the road. This should create a fog, as we know, and not only the fog just for computation, but also to add this intelligence to support some decision-making processes. Sorry. What we have investigated, we applied this approach. So we have saved some measurements. Okay, it's not that important now what kind of measurements they are, but we save these measurements in a dedicated database, and we apply some edge intelligence, so artificial intelligence algorithms inside the infrastructure, and these the results of the processing has been delivered in form of the context information to the platoons, and these were able to make the final decision. All the details, if you're interested in this research, these have been published recently on the Wireless World Research Forum, so all the details can be found there. In fact, in this case, we have applied some Q-learning approach. So very, in fact, we can say simple, but also it was intentional because we would like to minimize the number of computations, number of instructions, and data that has to be exchanged between the edge and the platoon. So there was an agent that was observing the situation on the street and suggest some strategies which band to select. But let me stress again that this is just a proof of the concept that there should be intelligence that will support this autonomous driving. So in fact, going into projecting this concept to this scenario, we're considering inside of this roadside unit, we have this Q-learning table, which learns based on the measurements provided by the platoons, and then there was a suggestion to select this or that frequency band to minimize the interference in order to increase reliability. And this is just a piece of results, but I'm not going into details. We are able to guarantee high reliability, and also we could minimize the number of switches between the frequencies. So the message I wanted to show is that even if we have this complicated scenario that you would like to select the frequencies dynamically, we have to consider many parameters around, and to guarantee low latency and high reliability, we are able to do this because there is some intelligence that support this process. In this case, I am showing just the reduction of the number of channel switches, which is also very important. So to summarize, because it's very short talks, to summarize, in my opinion, our opinion, what we are investigating is that there is a space for application of edge intelligence to support vehicle communication. The question is if it should be more centralized or distributed. So if this edge intelligence should only support the tracks, or it should make the decision. This is the question between the, in fact, CV2X or DSRC. And there are different advantages, but also many changes. And just to say at the end is that also we have applied the federated learning approach just to work on it further, and also work quite well. So let's conclude my talk. I hope that I finished in 10 minutes. So thank you very much for your attention.
Brilliant. Thank you for the
Thank you.
explanation, Professor Adrian Clicks. Appreciate that. Let's move on to the next speaker. Let me introduce Zaina Rahman from Glasgow, Scotland, to present on the topic of 5G satellite integrated projects at European Space Agency.
Can you see my screen?
Yes.
Yeah. Hi, everyone. Thank you for the kind introduction. My name is Zaina Rahman, and I am, as mentioned, I'm from the European Space Agency. I'm working in the area of space for 5G and 6G. So as an introduction, I'll discuss why satellites are important for 5G and 6G and the sustainability of our projects and what we have at our site in the UK, ESA 5G 6G hub. So why are satellites important? They play a critical role in the seamless networks to provide lucrative 5G and 6G economy. There are three main advantages of using satellites in connectivity. Number one being network resilience, so assured connectivity for critical applications and instances where terrestrial networks are compromised. So for example, if there's an application which requires a user to have, say, remote surgery, then you would want the network to be resilient and strong enough to combat that application. Next, we'd like ubiquitous coverage, so reaching areas where terrestrial 5G cell towers are scarce or non-existent for 100% coverage. For example, there's areas in Africa where there's no internet access whatsoever, so satellites would play a key role in ensuring that everybody there has coverage. And then finally, we have seamless connectivity, so allowing seamless transfer from terrestrial networks to satellite networks with no interruption for the user. So as mentioned before, applications would require the no interruption feature in this. And then moving on, sustainability. So in our projects, the 5G satellite enabled networks contribute to the United Nations Sustainable Development Goals for a better, greener and sustainable world. And how this is done is that 5G and 6G will provide the infrastructure to bridge the digital divide, and this then results in the growth, efficiency and sustainability, as well as satellites helping to reduce environmental impact. The 5G 6G vision will ensure that the access to internet is affordable, high quality, and easy to access. And there below are some of the sustainable development goals that we are addressing. So what we have new at our ESA site in the UK is a 5G 6G hub. So this is an area for collaboration with industry stakeholders, SMEs, etc., where they can come in and test their products with our 5G satellite terrestrial networks. We have an engineering lab, and we also have demonstrations and applications already in the 5G 6G hub. So the five main areas that we want to target using this 5G 6G hub. So Industry 4.0, this is where all the different vertical markets come in. For example, telehealth, autonomous transport, digitalization, drones, etc. And for these applications to take place, it wouldn't be possible without the connectivity being seamless and ubiquitous. We like to connect not only urban areas, but also remote areas, as mentioned before. But this all also has an economic benefit to it. There is a study that I read that 5G 6G will increase the economy by $3 trillion US dollars by 2035. And another area that we'd like to impact is humanity, so changing the daily lives of you and I. For example, during the pandemic, where we relied on the internet so much for education purposes, for connecting with friends, for work, working from home wouldn't be possible without it. So that's another area that we'd like to impact. And then finally, the space inspiration. So we'd like to inspire the younger generation, show how important that this is, also create jobs for them, and just show the impact of 5G across the globe. So with our 5G 6G hub, we have created it now during the pandemic, which took around a year. We're based in Harwell campus, so we'd like to integrate with the entire campus. We have this autonomous shuttle that we've just launched, and we'd like to integrate that with our hub. And then finally expand to a global scale. So we have talks with different countries around the world, for example, Japan, to work with them with our satellite terrestrial networks. At our 5G 6G hub, as I mentioned, it's an area where industry can come in and test their products and services with our networks. There are many different ways in which the internet can be connected. This is just one of the configurations. So here we have a user connecting to our radio access network, which is then connected to a satellite on the roof, up to the satellite in space, back down, and through our core network. This is just a simple diagram of what's going on. But there are many different ways in which satellite can be connected. We also have different modes of encryption to ensure there's safety and security of the hub. And there are different user equipments that can be used also. So this is our key visual that I'll leave you with. Just to summarize everything I've been mentioning, the different vertical markets, telehealth, autonomous travel, connecting the remote and the urban areas, to ensure that there's seamless, ubiquitous, and resilient connectivity. Thank you for listening.
Awesome. Thank you, Zaina. I appreciate that. That was awesome presentation. Moving on, let me introduce the next speaker, Amy Cameron from London, UK, to present on the topic, why 5G will transform telecoms the most of any industry.
Hi, everyone. Thanks for having me. It's great to be here. Nice to hear what everyone else is saying. So when I was invited to participate in this event, this is my first time. So I hope I'm on sharing the right kind of stuff. But my first thought was, in our research that we do at STL Partners, which is a research and consulting firm focused on the telecoms industry, understanding key strategies and trends and change that's going on and how the industry can grow. Yeah, my first thought was, yeah, 5G is going to have an impact on a lot of different industries, but first and foremost, it's changing telecoms. So I thought I'd share some of our thoughts around that. So, first I'd like to just quick agenda of what I'll cover today. One, that 5G is not here in isolation. Obviously, we've heard lots of chat about AI and analytics, edge computing, and telco cloud is the other thing that I would really like to bring in as another main part of the story. The second is then thinking about how hyperscalers are changing the supply of telecoms capabilities in turn to meet an ever-growing range of demands from users in terms of the connectivity they're looking for, and then finish with what this means for telecoms operators, or traditional telecoms operators, I should say. So starting with that first point, that 5G is not here in isolation, and actually what we're finding is happening is that 5G is a major catalyst of the shift of telecoms operations into the cloud. So here I've shared some data from a telco cloud tracker, where we've been tracking NFV and SDN and cloud network function deployments from telecoms operators over the last several years. It goes back to 2012, but haven't gone back that far here. And the main takeaways, you can see we've sort of showing lots of different types of deployments in terms of virtual CPE, SD-WAN, SDN, MANO platforms, cloud and NFVI and the core. And what you can see in this chart is that sort of the initial projects around NFV Mano and NFV infrastructure and SDN really drove deployments over the last 5 years. But the shift that's happening now is more towards 5G standalone and cloud-based functions. And that's why, for instance, at the moment, core is still a very big part of what's going on in the NFV SDN world. But things have slowed down because sort of all of the main starting point of virtualizing infrastructure has started, but that's only phase 1 of this project. The second phase is really moving into the cloud, and that's where we're going to get far more flexibility and a real, bigger change in terms of practices in the telecoms industry. So just diving into this in a little bit more detail, I thought I'd share some information on what the cloud deployments actually are. So a lot of this is happening in the RAN. So these is where we've broken out on the left-hand side deployments of Cloud RAN, vRAN, Open RAN over the last few years. And this is really, you can see, gathering pace. And on the right-hand side is, the shift from non-standalone 5G core to the standalone 5G core. And the standalone 5G core is really where we're seeing the deployment of network operations in the cloud for the first time at scale. And obviously we've had a little bit in 2020 and 2021, but these are the 2022 deployments are ones that we know have been announced, but have not yet been completed, in which we expect to be completed in 2022. And you can see that really ramping up this year. So that shift into the cloud for telecoms operations is really starting to happen. So there are many different forces that are driving this change. But, at STL Partners, one of the conversations that we've been having probably the most with all of our customers, both technology players and telecoms operators themselves, is what's happening with the hyperscalers. What is going to be their role in telecoms? How are they affecting industry strategy? Where should we partner with them? Where should we compete with them? Are they a risk to us? And what's really happening, and the way that we see it is that similarly to telecoms operators taking an increasingly verticalized strategy as 5G emerges, really shifting their focus from the consumer to the enterprise space, and how they can leverage their connectivity capabilities to deliver all the kinds of use cases that everyone is talking about here. Hyperscalers themselves are also taking a verticalized strategy, and telecoms is one of the key verticals that they are focused on. And so what's happening is we're moving from a standardized commodity products for everybody, and this is what telecoms operators were doing, with voice and messaging and connectivity, and likewise hyperscale players were doing with compute and storage and networking. And we're moving towards higher value solutions tailored for specific industries. So, moving together from network as a service, platform as a service, and software as a service, where you're combining a vast range of skills, business partners, and capabilities for many different industries. And the hyperscale cloud providers are targeting the telecoms industry as one of those opportunities. And obviously we have seen this with Microsoft's acquisition of Metaswitch and Affirmed Networks. We've seen that with its acquisition of AT&T's Network Cloud, with partnership between Dish and AWS as Dish rolls out its Greenfield network in the United States. And, I think that the key takeaway here is that as telecoms capabilities shift into the cloud, this is really democratizing access to those capabilities, right? It's not only the big MNOs that can leverage these capabilities. We're seeing this a lot in SD-WAN. Many of the leading players in SD-WAN are not the traditional MNOs. They are software first players that are meeting enterprise needs. And that is only going to accelerate. It's going to enable, far more programmable networks, far more flexibility. And I think that that's, one of the key things that we're seeing happen. And this is not just a 5G question. 5G is catalyzing it, but it's also because it's moving to the cloud. So, I think the results, I mean, you can already see where I'm going, is on the left-hand side, we kind of have the traditional telecoms structure, waterfall processes, siloed departments, and really just a pure focus on connectivity. And as capabilities become disaggregated, modularized, containerized, we're moving into a disaggregated telecoms operator where you have multidisciplinary teams and agile processes that are kind of creating continuous feedback loops between customers and partners and networks, and deep ecosystem development, and CI/CD processes. And these are all tailored specifically to industry needs, right? Obviously what's going to be necessary for supporting edge insights and analytics for V2X is going to be very different than what is needed for supporting, collaborative remote surgery, than what is going to be needed to support, manufacturing, from what is going to be needed, as a consumer moving around, right? We all want different things, and those connectivity needs are going to be merged together into end-to-end solutions for each of those end verticals. And that's really the need that we are serving and that everyone has to focus on. So I think, what this means is that we are shifting from a world where we had a few large-scale multinational operators, that are serving, mass market needs, that hold most of the spectrum. And you have a few players. You have some managed service providers that are tackling industry-specific needs, tower cos and MVNOs. But what's really happening is the democratization and the shift to the cloud and the disaggregation of the telecoms industry is resulting in a far more versatile market, where we're seeing the entry of new national mobile network operators, whether that's a Rakuten or a Dish or a Drillish 1&1. We're seeing tower cos move into private networks, deploying potentially some RAN services. We're seeing vertical and industrial MNOs, the likes of Bosch investing in multiple 5G networks, or Lufthansa investing in 5G networks for airports, and all the different needs that might be required in a port versus an airport versus a manufacturing plant versus a mine. And we're seeing lots of neutral host MNOs coming out as well, particularly to serve indoor venues that mass 5G networks might not reach well. We're seeing municipalities thinking about building their own networks to serve social care needs. Potentially, we're seeing some hyperscale MNOs. I mean, thus far, hyperscalers have not been that interested in acquiring their own spectrum, but we're starting to see AWS make announcements about 5G private networks. Transport operators have always had their own private networks. We may see those evolve and expand, and we may see all kinds of different things come out. So I think that this is the versatility that's coming out to meet a very diverse range of vertical needs. The reality is that mass market MNOs are not going to be able to solve all of those needs, and these players are essential in order to meeting the requirements that we have. And obviously, as Zaina says, also satellite MNOs coming out, decentralized MNOs, potentially leveraging some kind of blockchain or blockchain technology to support them. And that's really what the 5G era looks like. So I just want to finish on, what's the risk for telecoms operators? If we go back and think about, the shift to the cloud and the move to 5G, what is the industry trying to achieve here? First, trying to achieve more virtualized and programmable infrastructure, make it highly automated, make it more distributed, make it more accessible to third parties through API capabilities. And telecoms operators are making a lot of progress on this. Going back to the beginning of my presentation, we're really moving into phase 2 of the telco cloud project, with more cloud native deployments. But changing business practices, on the right-hand side, where you work in an ecosystem business model, where as as a traditional telecoms operator, you may be an enabler rather than owning the end customer relationship. You may be a lot more flexible. That is a lot more difficult to change for a traditional telecoms operator, and I think that's the risk for them is that they are less good at making the change on the right, allowing a lot of the new players to take up some of that high value solution creation for the end verticals. So I will stop there. I took a little bit longer, but I hope we're still kind of on time, and just say that, you know, there's lots more of this kind of thinking coming from STL Partners research and consulting in our events. And this presentation is hyperlinked. So we do lots of webinars where you can catch the kind of stuff that I've been sharing today in more detail. So thanks very much for having me.
Awesome. Brilliant. Thank you so much, Amy Cameron. I appreciate that. Now, moving on to the next speaker, let me introduce Raymond Pao from New Taipei City, Taiwan, to present on the topic of 5G plus virtual reality.
Thanks, Kinesh. Hello, everyone. I'm Raymond Pao from HTC. I'm a senior VP working for the business development. Today, I want to introduce how 5G private network empowers VR AR. You can see the devices on my back. HTC, we have been working in the virtual reality for more than 7 years. Our vision is Vive reality, where we believe the technology can merge with humanity to unleash humans' imaginations. So think about when you have the virtual reality, you can go to the virtual world, just like the Matrix or Ready Player One. And it is very hard recently, people call it metaverse, but we call it Vive reality. This is experiences we think people will gradually move from the current, most of the 2D interfaces like a PC, TV to 3D interface. But to achieve this virtual reality 3D environment, we need not only the VR AR technology, but we also need 5G, AI, blockchain, all this technology to work together. So HTC, we actually work with all of them. But why 5G is so important here? If we look at the recently, since the metaverse is so hot, we see the John Randolph, he brought this theory, the 7 layers of the metaverse. The fundamental, the core layer is actually the infrastructure. So Wi-Fi is the very important transmission protocol for virtual reality to help people to get access to the virtual reality with the great experiences. Let me show you a video. So in VR, when we launched the device back in 2016, we have a cable. We use PC or backpack PC to have a very immersive content to render and then show to the customers. But this is what we want in the long term, right? We want to have a much lighter mobility devices. Right now, we have some we call all-in-one devices. But if you think about the computing power, it is still not as good as PC or server. So in the long term, we do want to enjoy or give the user the best experiences, which is the high immersive, where you need a super strong computing power, but you want to have a very light and mobile glasses in front of you. Then we need a 5G to support us to reach this wireless connectivity to bring the best user experiences to the user. So that's why our 5G team, we work on this 5G protocol since 2017. We found out the ORAN architecture, which is the best practice for us. But also, we see there's opportunity for the enterprise, where HTC want to deliver the optimized private 5G network to support the enterprise digital transformation. Our key technology is the CU-DU software, where in Taiwan, actually, we have some advantage. We have probably the best ICT hardware companies in Taiwan. So we can easily to have so many partners. They bring the most reliable, affordable COX devices. So HTC, when we start to work on 5G private network, we decide we want to do the CU-DU software part. So we have all the Taiwanese ICU hardware partners as our friend. So our focus in the CU-DU software, so we partner with Intel. We leverage the Intel FlexRAN and to bring the connectivity up. And this is our partners in Taiwan, and we have more partners with different countries. For example, by leveraging the ORAN architecture 7.2, this is what we supported now. We can support different brands of radio units from Alpha, from FACA, from WNC, and there are more network equipment factories. They are building different radio units. And also with the CU-DU servers, it is the generic COX, so we can easily to find multiple vendors to provide us the standard server hardware from Supermicro, Quanta, Compal, Inventec, and others. With the 5G core, that's about the whole system, including the software and hardware. But I think Open RAN gives us lots of the flexibility, and we do see the enterprise, they have their different choices, depends on their company size, their use case, what's their applications. So we have been working with multiple 5G core system to make sure our RAN CU-DU can work properly. So we're in the lab, in the country certified the lab to test it with carrier grade 5G core like Nokia, Ericsson. We also tested with enterprise grade 5G core from Cisco, NEC, Affirmed, MetaSwitch, and we even test with two standalone core, which is more compact and more extendable. It's Untitled and Droid. So with all these partners, we are very flexible, and then we have confidence to provide very flexible solutions to the enterprises. And another key strength for our team is the application integrations. When we start to work on the 5G solutions, we know the application is the most important. So we start to work with our VR team. So the first application we bring to integrate with our 5G private network is our virtual reality headset. So we bring the VR streaming leveraging the 5G to Kaohsiung VIVELAND. And later on, I also bring the XR performance integration in our Kaohsiung Exhibition Center. And later this year, we will have another integration project in the Taiwan petrol company where they're going to leverage our 5G private network with a third-party smart AR inspection system. So we fine-tune our network to accommodate integrated with different applications. So this is what we have done in our VIVELAND. You can see a video on the top left. Before we have the 5G installed, there are 6 VR devices. They are very immersive, but there's a cable from the roof to the HMD. So we have 6 PC on the top of the roof. And all the users, they can play very immersive game, but they need to worry about the cable. So we have 2 to 3 operators just in the field, just to make sure they don't strap by themselves. But after we upgrade the whole system to 5G private network, we install the 5G network in the arcade, and then we can change the HMD from tether devices to all-in-one. So you can see the player. This is the live shooting. So they are actually just general, teenagers. They come to the store to purchase the ticket, so they can enjoy the content. Even they want to do some flip action, they can do it easily. So with all this 5G VR streaming, we see there are more enterprises when they want to build a training center. I think this is also a very good use case because they don't need to put a backpack or tether anymore. Even with the military or the design center, so they can bring the all-in-one, but they can render a very complicated, like the car model or like the architecture. So after we've been working with enterprises for the last years, we found there's a missing step. How can we help these enterprises? When they try out their applications, usually they struggling, how can they set up a 5G private network in their location? It takes quite an amount of investment, and they consider that for a while. So we decided we should help them. We should give them a very easy to set up a 5G private network for them to test their applications for 3 months or 6 months. After they see the benefit, I think it's very easy to convince their executive to install the whole 5G network in their factories or buildings. So we built everything, like we talk to our hardware partners. So we bring our portable 5G private network solution to the world. It is a carry-on box. I have everything in this box. It is only 32 kilograms. So I have a core system, I have a RAN, I have a radio unit, and I have a L3 switch inside. I personally carried this box from Taipei to Los Angeles in September timeframe. I check into the Taoyuan airport, I check out in LAX, and then I brought this carry box to my LA office and then set up the whole 5G network in 30 minutes. In this box, you can see the picture. I have a core, RAN, and radio here. And this empty space, when I travel, I'll put my radio units inside, I put all my cables. But when I go to my lab, I just plug in this box to my AC power, and then the network is on. I can have 32 devices connected, and I have 16 devices activated. I can support N41, N48, N78, and 79, depends on the different band. I can have different radio units with a very balanced downlink and uplink profile. But also, because of the different use case, we also have different profile to optimize the network parameters. For example, to facilitate the download centric applications, we have a specific downlink mode where we can have much higher download speed. For another use case like the uplink centric, we have been tested with some partners using the smart surveillance camera system. We can support 4K cameras with very low latency. And also I have a special VR mode where with this box, I can support maximum to 6 users to enjoy the 5G plus VR streaming in 30 minutes. So for the VR mode, I optimize not only for the downlink speed, but also the bit error rate. So for these different applications, we can have the different profile to fit for their applications. And this is the last page. When I leave my box in US, my colleague just bring the same box to CES. We just finished the show in Las Vegas. You can see the picture we put in the Wen Hotel, and all the VR contents, they are rendered in a edge data center, which is about 2 miles away from the hotel. But when I put this 5G box in the hotel, I can immediately provide the wireless. You can see the picture on the bottom left and bottom right. We can immediately provide the wireless streaming capability to the users. So my team set up the same demo, and then they want the same demo with the gaming content, with the training content, with the design content to all the visitors in the last 7 days. Thank you. And we do think 5G is a great achievement, a step to help the VR AR to do the next level. Thank you.
Awesome. Thank you so much, Raymond. I appreciate that. And let's move on to the next speaker. Let me introduce Dr. Ashwin Vadivelu from Perth, Australia, to present on the topic transforming healthcare and agriculture with 5G.
Can you hear me, guys?
Yes.
Okay, sorry. Very good day, everyone. Thank you, Mr. Ganesh, for the wonderful introduction. Just a brief introduction of myself, everyone. My name is Ashwin. I work as a postdoctoral researcher at Murdoch University in Western Australia, Perth. So I'm basically an environmental biotechnologist. I work mainly on aquatic plants and also on the conservation of the environment. So I'll be the first one to raise my hand and admit that I may not have a comprehensive understanding or as much knowledge as you all on the fundamentals and the working principles of 5G technology. But nonetheless, I'm fully aware of the huge potential and also the enormous benefit of this 5G technology and how it can help make a difference to various other fields, such as mine, which is the healthcare and agricultural sector. So this is what I would be talking about today. I will give you the core of my presentation today would be on how 5G can bring forward positive impacts and also help make a difference in both the healthcare and agricultural sector. So before I go into the main part of my presentation today, I would like to give you all a brief introduction on what is biotechnology. So biotechnology is basically technology or end products that are derived from living organisms or biological processes. Biotechnology basically exploits cellular or biomolecular processes to develop technology and end products that can not only help improve our lives, but also the health status of our planet. As you can see here, biotechnology is broken down to a wide range of different branches. We have medical biotechnology in terms of diagnostics and also the development of vaccines. We have agricultural biotechnology, in which we work to improve the yield and quality of food crops. And we do also have environmental biotechnology, which is my field of study, looking at the use of biological organisms to help improve the quality of the environment. Last but not least, we also have industrial biotechnology, which is the use of biological organisms or processes for the production of end user commodity products. On the other hand, we have 5G technology, which is not an extension of current practices such as 4G and 3G, but a total shift from a user-centric world to that one of a massive machine-type communication, enabling the connection of millions to billion devices to a high-speed network. 5G technology does not only help increase the capacity of devices being connected, but it also enables even the smallest devices to perform high-level computations and also connect quickly to processing power that is distributed throughout the system. As previously highlighted by the previous speakers, the major advantages of 5G technology would not only be the number of devices that can be connected, as previously mentioned, from million to billions, but also the added advantages such as fast and intelligent networks, the ability for back-end services, and most importantly, extremely low latency. So how can the integration of 5G into the healthcare sector help make a difference? So the integration of 5G into the healthcare sector is not only expected to significantly improve existing infrastructure or existing system, but it is meant to create a brand new, totally different health ecosystem. This new health ecosystem, which is powered by 5G and also aided and boosted by advances in robotics, Internet of Technology, and also AI, help meet the demands of not only patients, but also healthcare providers, making it much more accurate, efficient, convenient, and most importantly, making it cost effective. The ability of 5G technology does not only help remote healthcare support and help reduce the patient exposure to contaminants by minimizing in-person visits to doctor or healthcare facilities, but it also helped improve the overall experience. This is highly evident now during the pandemic, where we have restrictions in place for people to go out or seek treatment in hospitals or healthcare centers. So how can 5G technology help transform the healthcare sector? The sector which I believe would benefit the most is basically the telemedicine sector, in which the use of tools such as video communication and telecommunication devices are aided with 5G, high-speed 5G network to existing architectures that can support real-time video-based medical consultation. And this would allow for a significant improvement in the access to care and quality. Next up, 5G technology is expected to significantly improve remote patient monitoring. This is basically through the development and use of wearable devices. 5G basically will enable better connections on mobile devices, increase data transfer capacity, support larger blocks of data transfer, which would not only enable healthcare workers to give improved remote care, but also able to continuously monitor patients that are in risk. Next up, 5G technology in the field of healthcare can help create various opportunities to use augmented reality and virtual reality to care for patients, and also to train better clinicians. The use of VR for surgeons to perform mock trials would not only help improve their capacity, but also the ability to do so in a real life situation. Last but not least, in terms of the healthcare sector, 5G is expected to significantly improve data analysis by allowing a greater exchange of highly secure data needed for improved analysis of test results. And last but not least, allow and create a decentralizing healthcare model in which 5G will further accelerate the industry trend towards providing care closer to the patient instead of being in the hospital and outside the hospital setting, as you can see here, by the creation of walk-in clinics, outpatient surgery centers, and also home healthcare settings. On the other hand, the integration of 5G technology for food production on the farm is expected to help solve a major problem that we're currently facing, which is the production of sufficient food to cater the growing human population. It is estimated that by the year 2050, we would need to produce approximately 70% more food than what we produced in 2009. Therefore, the main aim of or main goal of the agricultural sector at the moment is to increase food production in the world while simultaneously decreasing the cost and environmental damage of this process due to the use of insecticides and pesticides. How can we do so? The only way to improve the production of food crops without affecting the environment would be through the development of crops that are able to withstand pests, and also producing robust plants with greater yield and ability to tolerate a wide range of climates and environmental stress. So how can 5G help make a change in this particular sector? 5G is expected to be the building block or the focus of a sector known as smart agriculture, or better known as precision agriculture. Smart agriculture is basically the use of Internet of Things, AI, or sensors to help not only improve the quality of food crops, but also increase the quantity of it while reducing manual labor power. Precision agriculture is basically precise treatments to crop. For example, instead of treating an entire field the same, farmers now have the power and technology to give personalized care to a particular individual plant or an exact row that needs attention. The beauty and the most biggest benefit of 5G technology is that machines that are currently used in farms can stay connected towards the farm network, even if they work out of farm. This makes the transfer and reliance of data instantly rather than and fast, rather than allowing for the data to only be transferred at the end of the day when the machines are back on site at the farm. The use of 5G technology is expected to create a wide range of different new technologies, such as irrigation control, weed regulation, sensors for farm animals, and also autonomous vehicles, which was talked about earlier, that would all benefit significantly from the fast data transmission that is being provided by 5G technology. As I mentioned earlier, 5G supports machine-to-machine services, which reduces manual human labor, but also at the same time reduces other inputs such as water, fertilizers, and pesticides. The connection of 5G to farm machineries and sensors will increase the amount of data that is currently available, and for other simultaneous AI systems to work, to get the work done properly and also instantly. As you can see here, the use of 5G powered tools on farm is already on way and is currently being applied. The most common systems that are currently being trialed or used are autonomous drone sprayers that are equipped with cameras and weed scanners that can not only detect diseases or problems to a crop, but they can also at the same time analyze and come up with countermeasures to prevent the pesticides growing and also the damage to the crops. So basically what happens over here is that you have a drone with an imaging sensor. It's able to detect the growth of pesticides, pests or disease in the plant. These imagings are then sent to the cloud, processed through the aid of artificial intelligence, and response mechanisms is carried out to help eliminate the pests or care for the plant. In terms of livestock production, this is where I strongly believe 5G can be a game changer and can help bring forward a significant change by improving the productivity and well-being of farm animals. Basically, what can be done here is that farmers and veterinarians can track the status, health status, and movement of a connected animal and receive daily updates on the animal's health and behavior. This would allow for the animal to be continuously tracked, potentially separated from the herd if they do have any disease that can be spread to other animals around site. So last but not least, so how can we move forward with the integration of 5G technology to both the field of medicine and agriculture? Because farm area covers a large area that are difficult to monitor, this sector would be benefit the most from remote data collection. By improving the efficiency of food production, we can improve not only crop production, but also the producers that is being produced. In terms of the healthcare setting, the use of mobile devices, sensors, and remote monitoring equipment is expected to grow tremendously by the power of 5G. And this would allow patients to receive imaging, diagnostic, and treatment that are more personal and quickly becomes a reality. Work needs to be done to first facilitate an end-to-end system. Enable systems must be able to connect to networks and the cloud in ways that they are interoperable and also secure.
All right, brilliant. Thank you so much, Dr. Ashwin. Appreciate it. Okay, let's have a free and easy Q&A among the speakers. Let me start first. I think this question is more towards to Professor Adrian, or maybe any other speakers can give your point of view. You know, like this edge intelligence for the autonomous. I have noticed that a lot of pilot projects are going on in for autonomous cars, particularly in Europe and US, or even some part of China. And the most recently, I think there was a news was announced by Mercedes-Benz, where they have actually coming out with the real life deployment of autonomous level 3 in Germany, right? So this is something really great, but I couldn't able to get the details of it. I was wondering whether how the deployment of the edge intelligence, are there any real case beside, or maybe Germany or maybe more countries are involved in terms of the real commercialized edge platooning for the autonomous, or is it still in the pilot stage?
I would say that it is It is still in the pilot stage, and at least to my knowledge, I believe that the development and investigation in the field of autonomous driving in general, these are evolving very, very fast. So my impression is that this intelligence applied here inside the car, between the platoons or somewhere in the infrastructure is ongoing. It is already there to some extent, but I would say that as even you have announced it in the release 18, there are some visions that there should be, let's say, the physical layer, the MAC layer, equipped with the artificial intelligence. And if we look on the standards and 5G and CV2X, then edge intelligence will be officially placed there the time. So there is still a lot of work to standardize it and to make it really happen. But I would say that to me, it's on the pilot stage, and some probably initial works where the intelligence applied is in that or other place of the network, but for sure it is needed.
Right.
If I could just jump in and add something, we've done some research at STL about 5G and transport, and one of the areas that we identified where there's some stuff happening is in sort of remote monitored or pre-programmed routes for public transport. So for example, Telia in Sweden is working with a public transport provider, and it's a short route. It's only a few kilometers. It's very well defined. It's a well-known route. So it's, there are fewer variables than, if you're just on a highway that's, in the middle of nowhere, or you're traveling between cities or what have you. And that sort of pre-programmed public transport route where the 5G base station is providing, a specific level of control and support and reliability that's been pre-tested, that's where we're seeing some advances happen in this field. It's a little bit different, but just thought I'd add that in.
All right. The other part I was quite fascinated, Amy, that you were, the cloud native and disaggregated, where like mobile operators like Dish Network, Rakuten, AT&T, I think more coming in, like Vodafone, they have tested in a separate region in UK as well. Yeah, it is picking up. At the same time, there are lots of traditional mobile operators who are still trying to against with this cloud native. They are not really cooperative. They are not in favor with the tier 2 vendors, the open RAN players and all that stuff. So I'm asking on a general perspective to you or anyone on the floor. In the long run, do you think the open RAN cloud native will take over the traditional eventually?
Yeah, I think you're completely right that, the shift to the cloud has been really trying for the telecoms industry. And, AT&T is like the Ferrari of the industry, and there's really only one. Rakuten is coming in greenfield. It doesn't carry the same kind of legacy burden as any other operator. And if you take a tier 2 operator, anyone outside of Deutsche Telekom, Vodafone, the leading operators in advanced markets, they just don't have the skills to be able to do this internally. This whole idea of a multi-vendor solution on white box hardware is incredibly difficult for most operators to achieve today. And so I think that in reality, they're going to have to wait until that technology is more evolved before they can use it. Now, if we dive into Open RAN specifically, that's an area where there's been a lot of discussion lately. It's very hot, a lot of trialing and testing. The reality is that this is happening in very niche, specific trialed areas, right? If you're talking about, a rural technology, a rural coverage where it's, very difficult to justify from an economic perspective for a mass market MNO to do on its own. And the sort of density and usage of those networks is much lower than what you see in the middle of a city. That's a good area to trial things. If you think about the most advanced operators, look at the Nordics, their 5G networks are all already deployed. It doesn't make sense for them to invest in Open RAN now. And so I think what we're going to see is, some of those middle ground that are a little bit lower on, a little bit further behind on developing their 5G are testing Open RAN, and it will become the norm, but it's going to take, probably closer to 10 years than 5 years to get there. And And that's our viewpoint at STL. I mean, I can see the others have their hands up. Maybe they have a different perspective or can add to that.
So Amy, this is Raymond. I'm very interested in the last couple pages, like you mentioned, there will be many different type of vertical MMOs, like decentralized MMO or like CT MMO. But I wonder, how do you see the spectrum? Because I see the spectrum probably the most difficult challenge for these new business models coming out.
Yeah, and you know, that's really, like, in our opinion, that's a really market by market change, right? So every market is going to develop differently, right? Like, obviously you've got Germany, where enterprises can buy their own spectrum. You've got the United States with the CBRS spectrum, which I think is really one of the most interesting plays, right? Because a lot of the CBRS spectrum, the licensed CBRS spectrum that is available, it actually covers a really broad geographical area, and it's not feasible for most, you know, enterprises to buy something at that broad reach. So you've seen utility companies that, you know, operate over a large space buy that spectrum. But what's developing or starting to develop is potential for a secondary spectrum licensing market, right? So in the UK, this exists. Telecoms operators can sub-license their spectrum in a specific geographical area, where that can happen in, you know, with CBRS. And I think we've got Google and Amdocs are developing the platforms to enable that secondary spectrum licensing market. And I think it'll develop differently everywhere. But my personal perspective, and I'm not sure all of my colleagues would share this, is that eventually in most markets, there will be some way for non-traditional players to access that spectrum. And there's always unlicensed spectrum, and there are challenges with that that can be circumvented in some degrees. But I think that that's generally the trend is going to get there. And it's really, you know, it's not because MNOs are not trying, you know, particularly if you look in the South Korean market, like MNOs are doing loads of really cool stuff. But the reality is they're mass market players. They cannot serve all of the individual niche needs. It's not about curtailing their business opportunities. It's about ensuring that all verticals can meet their needs and that there is opportunity for people to be able to support those needs. So I think that we'll see the sort of localized spectrum licensing market sort of shift quite a lot over the next few years.
Thank you.
I think
I will just
there was a good
compliment.
Where, you know, I just want to add just a few lines here. You know, quite a number of countries that is been dominated by the government regulatory or even monopolized by the traditional players, not really in favor with the local private networks and all of that, right? So there can be some sort of influence towards the regulators. But look here, like players like Amazon, they came out with a fantastic AWS 5G private network end-to-end together with the bundle H solutions, right? I think that is a fantastic way of how they want to trigger, particularly in the US market. If you see from a hyperscale point of view, how they are trying to come in the telecommunication operators territory, you know, to eat up those 5G private networks. Because if you see the traditional, most of them are still in the 4G LTE private networks, like Nokia has done a huge number of deployments in the LTE, but we can see very few on the 5G private networks. I think Germany has much more dominated in that part of region, where they have given about 140 plus licenses, particularly in the manufacturing sector, automobile industry, and so on and so forth. So I could able to see some of the countries, if they keep push hard, I think that can able to influence other countries to have that the benefit of having our own local licenses.
Yeah, I could just maybe comment briefly that maybe 1 or 2 years ago there was a visionary presentation that I mean, that's summarize somehow this question and the answers. I mean, to some extent, that there was a vision of the telecom market that there will be the you know the infrastructure layer, with all the telecom codes and so on. The service layer, and on top, answering the question, there will be also a spectrum layer where you have a dedicated companies just applying some intelligence to manage spectrum. So many different approaches. Maybe this is the way how O-RAN and also will evolve.
Thank you.
Was Raymond, I think there was one part interesting. You were mentioning about the VR, right? Everything seems so nice when it comes to the pilot. I was just wondering, in terms of the commercialization, when it comes on the real life, where the consumers can able to use on a large mass scale, I wonder how the mobile operators can able to package it up. The reason why I'm asking this question is that each of these devices, the headsets, they depends on the what kind of content, right? I think it can go up to 1 terabit per second of data, right? It's huge content of data. And in terms of streaming those data, depending on the locality, right? How far towards the mobile operator and towards the consumer and everything. I wonder how the mobile operators can able to package the right price models towards the end users.
I think this is a good question. I think this is still some way to go. There are a couple items related to the price perspective. For example, to render the VR content, you really need a quite strong, powerful server. So for the data fee or server fee, that will be quite expensive. But the other one is about the user experience, like for the cloud gaming or cloud VR, right? If you go to we call the cloud, like really a data center far away, the latency is really a challenge for the consumer launch. Like if you cannot guarantee the certain latency, actually it's not a good experiences for the end user. They won't pay for it. So I think from the current VR use cases, all the way to the consumer, they can bring the VR devices streaming from the somewhere in the data center. That's still somewhere to go. But I think that definitely the reason HTC we put the private 5G network together with VR, we think for all the enterprise cases, it's controllable. You can have on-premise server, you can have the edge partners, and your network, you don't need to send the data to Oregon and then to New York and come back, right? You just 2 or 3 miles away. So all the latency is under control. So we can leverage this 5G private network to provide really a high quality of the data transmission.
Right.
Could I ask a follow-up question to Raymond? I'm curious to understand who you see as the key customers for your network in a box. I thought the demo was quite cool, and I can see a little bit, but I'm curious to understand, who that's most valuable for in your customer base.
So we actually have two. I have two level of the solutions. One is the box. The box, the key feature for that box is you're easy to set up a 5G private network. As long as you bring somewhere, you set up in 30 minutes. So I think that one, because when I'm in Taiwan, I see there's lots of factory, they are talking about the digital transformation. But the first investment they need to do is to build up the 5G private network. The carrier is not interested to just build a small room for them. You need to build a whole factory, and they don't want to really invest before they prove their digital transformation application is working well, or the ROE is capable. So I think our box is try to solve this problem. We help them to be able to set up the 5G private network in a very efficient way, so they can pilot run their use case applications 3 months, 6 months, and then after they verify everything works well, they can adopt into their whole factory campus. So that's my box. And for 5G VR, actually, my customers, I want to sell for the, for example, LBE use case. Like that's what I'm adopting into the Kaohsiung VIVELAND. But also, they are enterprises when they do the VR training, like the training center. Before, if they want to do a very immersive VR training, they need to buy maybe 10 or 15 PCs and put it in the classroom, and then they can start to have the employee to train. But with this capability, they have some server in the building. They can do just streaming to the classroom, and also for the schools or even the design center. If you have 3 or 4 designers, they want to using VR to view the same design object and then to have some discussion. I think that's the way. How can we balance the data server and also the VR quality and also the mobility of the VR device?
Thanks.
Yeah.
Anyone else have any questions?
Yeah, just maybe a brief question also regarding this box. I was curious because you said that this is ORAN compliant. I mean, is it a black box or someone can install their own XApps or modify the content, or how does it work?
You mean my device?
Yes.
Yeah.
Because I
Yeah,
remember
basically,
it was UGBP and ORAN compliant.
Yeah,
I saw that.
So, yeah, so my network is you provide a 5G network. So on top of it, there's no constraint what kind of application you're running. So any XR applications, any XR devices is up and running. Kind of like I'm a replacement for the Wi-Fi. You know how Wi-Fi get interfered in the public space, and for the 5G, we can have a guaranteed quality of services for the VR.
Okay, sure.
All right. So if there's no any questions, then I would like to end this session with thank you. I'm so grateful to all of you to be here. And this session will be ready to be uploaded on YouTube today in a couple of hours time. And please do feel free to share to your colleagues as well. And thank you so much. I so appreciate to all of you to make this event happen. Let's keep in touch. You never know, we may meet again. So thank you again. Thank you so much.
Thank you so much.
Thank you.
Thank you very much.
Thank you, everyone.
Thanks,
Nice meeting you.
everyone.
Thank
Thank you. Have a good day, guys.
Have a
Bye.
good day.
Bye.
Bye.